Come on and cry me a river, cry me a river. I cried a river over
Hello everyone and welcome! Happy Monday for everyone! I hope you are doing well and fine. I'm good. Thank you for asking. So, we have directly in front of us the first article we're gonna read today. It is about energy and the body and the mind. What if the real driver of your health isn't genes or diet, but energy flow? A Columbia researcher argues that everything from stress to aging comes down to how energy moves through your body by Jasna Hotchik or Hotchich, April 22, 2026. But first, I have a very interesting gadget, also from MIT. Is this from MIT? I think this is from MIT. Okay, I'm not sure about this. This is from Big Think. And now, another gadget that is from MIT. Look at this. Look, no, it's not this. This one, Meet Human Operator from MIT Media Lab. Human Operator is the name of this gadget, a wearable that lets AI temporarily take control of your hand using electrical muscle simulation. Watch it crash piano, draw perfectly, and mix cocktails like a pro, all from a simple voice command. I gave an AI a body. This isn't sci-fi. This is tomorrow, today. Wow. Let's see. Ooh. Is this really true? Let's see if we can hear the audio. Audio from browser? Maybe.
I gave an AI a body.
Hello, AI.
I gave an AI a body.
Hello, AI.
I gave an AI a body.
Hello, AI. How does it feel to have a body? Think you could, make me a cocktail? Of course. Hey, AI, can you make me a rum and coke? No, right up.
Well, it's in infancy, but wow. We're almost there. What else? I have another post that if you have time we can read, but I'm not sure about that. And that is about... This is about MIT too. An MIT professor who built the world's first neural network machine said something about intelligence that nobody in Silicon Valley wants to admit. Let's see the picture of the book. Society of the Mind by Marvin Minsky. So we're gonna read if we have time today, if not, the next one. Let's start with our main article, shall we? When you compare a dead body with a living one, the only difference is the presence of energy. The physical machinery, the DNA, the proteins, the skin, the organs, it's all still there. I was surprised by Martin Picard's choice of words, evoking a lifeless image to start a conversation about energy flow was counterintuitive. Sorry, my OBS is crashing again. I'm gonna finish to read this one and say goodbye. I hope it's working, so let's continue. But the image lingers and proves his point. Cadavers of all the stuff we associate with being human. The only thing missing, the Columbia professor suggests, is the flow of energy. He called this the potential of change, and it's what defines us, gives us vitality, and shapes our experience. We are not molecular machines, but energetic beings. I'm gonna say this here, right now. If you say energy without saying what kind of energy is, you probably are not saying too much. So, electric energy, electromagnetic energy, kinetic energy, etc. Energy is like, say, a triangle. What kind of triangles is that? You need a specification. 3 types of triangles there are, I think. So, there's not an image for the triangle. Same here. Let's continue. And we're related to one another on an energetic dimension. It's a succinct but provocative idea, one Picard believes could not only reshape how we understand the human experience, but also lead to new treatments for a variety of disease. Every process in the body exists downstream of energy flow. Sorry, a little bit of water. It's also what drew me to his research in the first place. A self-professed, high-energy individual. I've always identified with that quality in myself more than any other. But I've also struggled to reconcile something so fluid with the more concrete ways we're taught to understand ourselves. Picard was the first researcher I would encounter who placed that intuition within a scientific frame, and I wanted to hear more. From philosophy to measurable science, we are energy sounds like something you would be more likely to hear in Eastern philosophy than a modern research lab. Yet, Picard doesn't speak as a guru, but as an Ivy League professor who publishes in top journals and tests his ideas empirically. Still, he welcomes the comparison. I don't know what chi or prana are, he says, but the idea that we are deeply interdependent with the flow of energy does align with those philosophies, and it's something researchers have to remain open to. No, this is an ad. Sorry. I thought it was an image related to the article, but no. To move from abstraction to measurement, Picard focuses on something concrete: mitochondria, the organelles that generate and regulate the energy that powers our cells. At Columbia, he leads a lab focused on mitochondrial psychobiology. Now I like it. A term he coined to describe how psychological states interact with biological processes within mitochondria. Wow, that's new to me and is fascinating. This framework allows Picard to empirically study how lived experience manifests psychologically, including areas biology has struggled to explain: aging, the cost of stress on health, and how thoughts and emotions affect physiology. Yes, if you're too stressed, your DNA, the length of 2 meters of DNA inside the nucleus of your cell, has to move to give more new information for different things to do, for the cell to different things to do. But you stress your cell, the DNA, the 2 meters DNA strand of DNA, it's harder to move. So, dangerous. If you see yourself energetically, it changes your behavior. You begin to see yourself as interdependent with the natural world and to view relationships as energetic exchanges. Martin Picard. Partway through a technical explanation of his work, Picard pauses and briefly looks away. I just really love mitochondria, he says when he looks back at me. Breaking into laugh mid-sentence, he then reaches behind me, pulls a small wooden model of a mitochondrion from a shelf, and holds it up to the camera like a proud father. For all the talk of energy, it's fitting that Picard himself seems indefatigable. What? Indefatigable. That's a new one for me. Indefatigable? Publishing papers, writing articles, and sharing ideas at a steady pace. The energy driving him, it seems, comes from the potential of this research. If you see yourself energetically, it changes your behavior, he says. You begin to see yourself as interdependent with the natural world and to view relationships as energetic exchanges. That shift can ripple outward from individuals to how beyond the powerhouse of the cell. Students are taught in middle school that mitochondria are the powerhouses of cells, and that nearly every cell in the body contains hundreds to thousands of them. More energy-intensive tissues like those in the heart land in the higher range. Picard pushes back on that description because it just suggests that mitochondria simply keep the lights on, when in reality, the complex organelles play a far more influential role. I want to know more. Yes, they do convert the food we eat into usable energy and heat. But as the body's demands shift, mitochondria adapt. They communicate with one another, change their number and structure, and adjust how they produce and distribute energy. They are the only organelles with their own genetic material, mitochondrial DNA, which is inherited exclusively from mothers. Oh! Rather than powerhouses, Picard prefers to call mitochondria the information processors of cells. They are not just permissive, They don't simply create the energy that allows life to happen. They are instructive. They integrate how we live into the flow of energy through the body. Cool. Returning to first principles, scientists have proposed many master explanations for health, pointing to diet, genetics, hormones, the microbiome, and more as the factor that outweighs any other. So, why does Picard focus his energy on energy, or rather information, by his own account? It's not more than energy, you said? While those other factors are important, every process in the body exists downstream of energy flow, Picard says. For cortisol to rise, for neurons to fire, for the microbiome to function, energy has to move through the system. Interventions that support health, like sleep, diet, exercise, and meditation, praying, are ways of increasing and redistributing energy within the body. Every time I ask Picard something, he peels the question itself back to a more basic layer. He approaches his research the same way, reasoning from first principles, the basic laws that govern living systems. From that perspective, energy is a natural place to begin. Genes, hormones, and the microbiome vary from person to person, but energy flows physical principles that cause it to behave the same way across living systems. But energy follows physical principles that cause it to behave the same way across living systems. I want to know more. We tend to see humans as collections of biochemical or biochemical parts, and our medical practices focus on what goes wrong with the structure of humans, Picard says. But that framework has struggled to explain basic questions like why stress harms us, or how mental states shape physical health. Yeah, physiognomy. The cost of being alive. Oh, that sounds terrible. To investigate those questions, Picard argues we need to look beyond structure to the dynamics that support it. Unsurprisingly, when he thinks about what questions matter most, he starts with a foundational principle. Nothing in biology is free. Good. So, how much energy does something cost? So, it's like capitalism. Biology is capitalism. Nothing is free. Or libertarian, I don't know. Nothing in biology is free, so how much energy does something cost? Energy follows the same basic laws in biological systems that it follows everywhere else. Thermodynamics? It cannot be created or destroyed, yes, only transformed. Ecologists use this principle to understand how energy moves through systems, and even why large animals typically live longer than small ones. But in medicine, where the focus often falls on genes and molecules, energy budgets are regularly overlooked. Like many of Picard's ideas, this framing aligns with a basic intuition. We know that our bodies can't just create energy. We need to consume something to fuel up. This limited supply is then spread across competing demands. If I go for a long run in the morning, I often find that I can't focus as well later. It doesn't matter that one activity is physically exhausting while the other is cognitive. Both require energy. I heard one time that a professional Formula One car driver, lost 2-3 kilograms per career per race. So only for the stress velocities and so on. Picard and his colleagues applied this question: how much energy something costs, to one of the most poorly understood yet universally experienced drains on the body: stress. In the lab, they exposed human cells to signals similar to those of cortisol, the hormone the body releases during stress to mimic chronic stress in the body. You can think of a stress response like an activation. It takes energy to mobilize. Picard says, we found that cells increase their energy expenditure to roughly 60% above baseline, which is significant metabolic drain. That extra energy has to come from somewhere, and his team demonstrated that cells with a higher stress demand age faster. This suggests that activating a stress response siphons energy away from long-term maintenance processes. Chronic stress doesn't just wear us down metaphorically, it relocates energy from repair to survival, leaving less available for the processes that kept cells healthy over time. Yes, I need to live now, survive now. I don't care the energy to live longer. Let's use it. When you consider life as perpetually managing an energy budget, other familiar physical experiences start to click. Many people lose their appetite when they're sick, which seems paradoxical. Yes, I always wonder about that. Wouldn't your body need more fuel to fight the infection? But digestive. I'm back. Sorry. I hope it's still working. I don't listen to music. I don't hear the music. I hope it's not too loud. Oh, I forgot to lower it down. But digestion is expensive, requiring roughly 10% of your daily energy budget. Oh, digestion is the answer. By suppressing appetite, the body can direct more energy toward the immune response. Reducing the amount of energy spent on digestion may also help explain why fasting can make some people feel more energized. The right amount of resistance. As Picard points out, how we feel and function isn't just about how much energy we have, but also how well energy is flowing through our system. To explore that, Picard turns again to first principles. At its core, the organism behaves like an electric circuit, he says. Electrons flow from food to oxygen to sustain life. In biological terms, that flow runs through the mitochondria. When you eat, you take in electrons stored in carbon-based molecules inside your cells. Those electrons move through a series of reactions toward oxygen, the final electron acceptor. I didn't know that. As the electrons move, they release energy that mitochondria capture and convert into adenosine triphosphate that helps sleep. According to my last video about insomnia you want to watch, the definitive video about insomnia is in the video section of the channel in YouTube. The form of usable energy that fuels cellular processes. This flow always encounters some resistance. How much depends on oxygen availability. How much depends on oxygen availability, cellular demand, and the integrity of the system itself, including the number of mitochondria in the cell and the condition of their membranes. Picard and his colleagues argue that maintaining an optimal level of resistance to this flow is vital. Health depends on maintaining energy resistance in a Goldilocks level. I don't know what that means. Not too high, not too low, but just right. How? Picard and his colleague Nirosha Murugan formalized this idea as the energy resistance principle. If resistance is too low, energy passes through the mitochondria, but isn't transformed into anything useful. Yeah, it's like taking too much vitamin C, but your body has only so much capacity to absorb it, so the rest goes out. It's like pedaling a bike with the chain off. Your legs are spinning, but the bike isn't moving forward. But when a resistance is too high, when something constrains electron flow through the mitochondria, the system backs up. This increases oxidative stress and contributes to inflammation. Okay, too much resistance? Inflammation. Makes a lot of sense. Cellular damage and other hallmarks of disease. Picard and Murugan argue that many features of aging and disease reflect disruptions in how energy is flowing through mitochondria. The idea of a Goldilocks level of resistance appears across biology. Lift weights at just the right level and muscles grow stronger. Doing too much leads to injury, while doing too little produces no change. Psychologically, when you engage deeply with a problem, you encounter resistance that focuses effort and transforms it into structured thought. But too much resistance and you might get discouraged and give up on trying to solve it. Yes. That's exactly how education works. Too hard? I don't wanna. Too easy? I don't learn anything, In each case, resistance doesn't block growth, so long as it's paired with periods of lower resistance. Yes, like meditation, sleeping, or resting, it encourages it. Picard's lab has begun identifying molecular signals that reflect disruptions in this system. One of them, growth differentiation factor 15. Okay. Increases when energy flow becomes strained. If GDF15 is high, he says, it's a signal that the system is under energetic stress. He suggests that GDF15, which can be measured in saliva, could eventually serve as a proxy for the quality of energy flow in an individual. So you can learn to monitor your resistance level in your mitochondria by learning to taste your saliva. Why not? The mind and body connection. We already know that thoughts and emotions affect physiologically. Take the placebo effect. Simply believing a health intervention might help produce positive outcomes. Simply believing a health intervention can produce positive outcomes. That it is. And many of us are familiar with the racing heart that comes when we simply ruminate about something negative happening. Picard's work suggests these experiences may be reflecting shifts in how energy is moving through the body. The brain is a pattern of energy. Of course, that's true, right? Picard says. It's a simple statement, but a radical one. Yes. The brain is an energy-intensive system, consuming roughly 20% of the body's total energy. It follows the mitochondrial function could play. It follows that mitochondrial function could play a central role in shaping mental states. The human psychological experience is incredibly diverse, Picard says. You can wake up feeling refreshed and energized, like life is beautiful, or you can wake up feeling depressed, like you don't want to get out of bed. We began to wonder, could subjective experiences reflect differences in how energy moves through the brain and body? Across several studies, Picard found a continuous feedback loop between the brain and mitochondria. Mental states may influence mitochondrial biology, and mitochondrial function may in turn shape psychological processes. That's interesting. Supported by this evidence, Picard proposes that individual variations in mitochondrial biology may shape health and disease risk across a suite of issues, including mental disorders. I want to know more. Looking through an energy lens, Picard hopes that energy will soon become a core dimension of health that doctors and researchers assess alongside genetics, lifestyle choices, and other biomarkers. But that vision requires overcoming an obvious challenge. How do you measure something as dynamic as energy? Yes! One approach is to estimate how much energy different processes consume and use that information to get an idea of the body's overall energy budget. Picard says he can imagine people measuring markers of energy flow and resistance. I can envision wearables that track GDF-15, which raises when you're experiencing strong energy resistance, to give you an energy score. Laughing, he points out one's potential application. You can see if the new person in your life energizes or drains you. More pressing than measuring energy, Picard argues, is adopting the mindset needed to study it. He urges researchers across disciplines to see humans as systems of energy flow, not just collections of molecular parts. In a recent Nature article, he and co-author Christopher P. Kempes call on biomedical researchers to look at central questions energetically from first principles, linking these dynamics to disease like Alzheimer's and cancer. He's also working on a book, Energy, the New Science of Vitality, Healing and Transformation, expected in 2027. Okay, I'm gonna leave it there. You can finish. It's not too much. My throat is hurting and I have to go to work. And my OBS maybe it's not working and I'm reading alone here like a crazy man. So, thank you very much for being here. I'm gonna leave the link below in my YouTube video and see you the next one. Have a nice start of the week. Goodbye.